So, like I said, I think that related rates has a little bit of an undeserved reputation for difficulty. So what I've done really is I've broken down how to solve a related rates word problem into I've never done this before, but I'm going to give it the name the Ullman method of solving a related rates problem. It's probably not all that unique. Maybe I shouldn't put my own name on it because it's really just cobbled together from several different textbooks. I picked the things that I liked and put them in a list. But I do find that when I do this in a live class, by the time we've done problems for about 20 minutes, I've got everybody thinking about the problems in the same way that I do. They're setting them up, solving them with very little trouble. So just try to try to absorb this method. The first thing you want to do is assign variables and be very, very precise about that. You don't want to just say something like, like x is distance. You want to say x is the distance in meters that the object is to the right of a wall. In other words, just talking about distance, if I say that something is a distance of 5, 5 from what? Where is it? What direction? And what units is it measured in? You need to be very precise about what each variable means. If I say t is time, is it time in minutes, centuries, hours? Is it, and time since when? So you need to be asking those kinds of questions. Second step is to write the rate the problem is looking for in the form of d one variable over d another variable. Again, we'll get to an example of that, but the point is that we're almost always asking for a rate with respect to time. We're asking how fast something is moving away from something else, which means we're asking how at the rate at which some distance is increasing with respect to time. So that would be something like dx over dt, or maybe we're asking the rate at which the area of something is increasing with respect to time. So that would be dA over dt, where A is area. So once you've assigned the variables, you're going to be able to very precisely state in this form what rate the problem is looking for. Number three, you want to find one or more equations that relate the variables. These are not usually going to be derivative equations. These are going to be these are going to be usually just ordinary algebraic equations, although you are going to extract from the problem any rates that are given as part of this step. Four, since number three is usually going to have algebraic equations, you're going to differentiate, and that will often involve doing something using the chain rule and/or implicit differentiation in order to differentiate the equation that you have. Not always, but sometimes, but often it does. Often it involves implicit differentiation. Sometimes it's just a straight derivative of a function. But you're going to use all the tools you have to differentiate in order to perform step four. And then finally, you're going to use the derivatives that you found in step four to find the rate identified in step two. And then you're done. So what I've done is I've given a couple of different related rates problems in that it will follow, and I've set up items 1, 2, 3, 4, and 5 so we can see how to apply them to each problem. Um, One thing to note is that the problems that I've chosen are pretty much the types of problems that exist. There's a common sort of refrain that, I took the test and the problems look nothing like the homework problems. I can pretty much assure you that in this case that's not true. I mean, I can pretty much assure you someone's going to say it, but it's not true. It's almost all of these problems involve things like spheres, surface areas, volumes, triangles, very big on triangles, very big on right triangles. So even though the exact setup as to why we have a triangle may be different, or the exact setup as to why we're inflating the balloon maybe, with a surface area and a volume may be different, these problems all follow very, very similar templates. Um, so hopefully you'll see that there really aren't that many different types of problems along these lines.